Okay, in this part I would like to discuss about the snappyHexMesh, which is a very crucial technique or tool that you have to understand in order to make a more realistic OpenFOAM simulation, because by using block mesh you can actually do a lot of projects by it, but it is limited to some simple geometry. And by using snappyHexMesh, you can actually import your own geometry for your CAD modeler, let's say, from the SolidWorks or maybe Autodesk Inventor, Fusion, or maybe like a FreeCAD and anything like that. And you can actually build your mesh to run in the OpenFOAM by, converting it to the mesh with the help of snappyHexMesh. So, the snappyHexMesh itself is basically you prepare the block mesh like this for the regular block mesh. Then you can import or prepare your geometry in the format of STL or OBJ, depends on your CAD geometry exporter or your modeler to export. And basically, the STL surface here we will discuss later in the Blender, so we can split it face by face, like define where is inlet, outlet, and walls, let's say. And by running the snappyHexMesh, actually this block mesh will be split by the STL surface. Let's say if we have this kind of block mesh with regular size, the presence of this STL within that block mesh will split the mesh into the smaller mesh, and in order to fit the size of the geometry of the STL, then after the geometry is fit to the mesh, then it will be removed like this. And the final step of the snappyHexMesh is to actually do the snap of the cell nearby the walls into the STL surface. So it is also, that's why it's called the snappyHexMesh, because it is like snapping to the surface of the STL. And this process will create a beautiful mesh with have also the regular hexahedral mesh outside the geometry, so it will maintain the effectivity of the hexahedral mesh while also capture the detail of the geometry. This is very efficient if you want to design, let's say, a very large room with maybe some small objects within it. You don't have to worry about make the mesh small everywhere, but you can just focus on your object. And it will be more beneficial if you also understand the grading, which we discussed previously in the block mesh grading. So before go to this topic, I hope you already seen the previous topic about the block mesh, because actually the basic or the background mesh for this snappyHexMesh is the block mesh itself. And let's go to our example, which is we will simulate the pipe or like object which is like pipe that we will make the mesh with the snappyHexMesh. Let's just open our preview, and I will provide this file for you in the download. Sorry, I need to delete this first. I will give you this folder because it is not a native OpenFOAM tutorial file. Okay, so the STL file or the OBJ files that we have prepared are stored within this within this constant and also tree surface. So it's called tree surface because STL files actually are generated or constructed using the tree surface. Let's see our STL files here. Let's open. We will discuss these files using Blender later. Okay, here we go, our model, and if we see the surface with the edges, it will be shown in the triangular or tree surface. That's why it's called the tree surface. Okay, the next step to do is check our block mesh, which I have created by following the bounding size of this geometry. You must make sure that the units and the size are correct, and we can leave the boundary to be empty because we don't need this for this internal flow, but for external flow maybe you need the boundary and create the object inside this domain without removing the boundaries. But for this internal flow, maybe we don't need this boundary. So yeah, just go to the trial 6 and run the block mesh, and here we go. Let's touch the block mesh and let's check if the mesh is surrounding our object. Just click apply. So a little bit fine, so it's okay. Then we can change the view to the wireframe to check that this block mesh is surrounding the object, because we need to split inside that object. So here we go, we got our block mesh and our STL file. Then I can run the snappyHexMesh by simply snappyHexMesh, but it will be error by showing that it has like a empty region. It means that we have some empty regions within our boundaries, and we need to edit this. Let's say we want to make it as a wall. It is just like a dummy wall because it will be removed after the mesh finished. Okay, just try to run it again, because the default of the boundary will be empty if we not input the the boundary for the block mesh. Okay, while running this mesh, let's check our snappyHexMesh dictionary. So in snappyHexMesh dictionary, we usually also need to copy the mesh quality dictionary, which will be also run by the snappyHexMesh. So this is basically our snappyHexMesh. Here we have the object which called the wall STL, inlet STL, and outlet STL, and make sure that it's like a tree surface mesh because it is stored within this constant folder and tree surface. And this is actually the name that you want to set the patch. Let's say if the name is like a walls obj, but you want to rename it like wall A, let's say within the boundary it will be also the wall A. And this is some constraints for the quality, but you can tweak it a little bit if you want. But maybe one that is commonly redefined or tweak is this number of cells between cells. So if we make this number larger, it means that the growth rate of the mesh of the refinement zone will be also larger. If I use these two numbers, so the growth rate, it will not go far from the STL file, but if let's say I use 10, it will be like a larger growing refinement. Then the refinement surface itself will define the number of the refinement. The larger the number, the larger the the finer the mesh, it will be shown here. For let's say here I have this zone with the large block, and if we refine it with 0, it will not change. It's just like a snap to the object. But if we refine it into 1, it will be like this. So it will be split into 4. If we refine this 4 block mesh into smaller, like the second refinement, it will be like this. So it will be, like smaller and smaller divided into 4. So that's the idea of the refinement. And also this one is very crucial to define. So our mesh will generate inside this tree surface. So I need to make the point inside this tree surface. But if you want to simulate the external flow, let's say you want to maintain this block, but you want to cut this cell, so your your inside point should be located around here or here or here or here. So if you look at the inside point inside here, it will be like generate the mesh inside this. You can actually make the measurement by using this let's say this point here, or maybe using the ruler if you want to make some check to where to check the coordinate. Or you can actually just use your CAD modeler to check the geometry. Okay, we actually finished the running of the snappyHexMesh. You can check the the quality, but it's okay. Then we can touch again foam.foam, and here we go. Let's reload the file, and you will notice that we have now have like inlet, outlet, and walls from the snappyHexMesh. And the time we will have like 0, 1, and 2, because actually what snappyHexMesh do is making the first by using the castellated mesh. Let's just check what is castellated mesh. By first, maybe I will split it slices, or maybe clip using this clip to oops, I guess I should. Yeah, it's okay, maybe just change the orientation. And let's check surface. So this is our mesh. So the first mesh is actually the castellated mesh, it is like cropping the mesh like this. Or if we see this image, this is the first, or the castellating, and the second one is the snapping, so it will be snapped to the STL file, and we just can ignore this. Okay, this is our mesh. You can actually make also the layering if you want to capture the boundary layer, but maybe in this in this case we will not need to do that, because sometimes it will make if your geometry is not good enough, it will create poor mesh quality. And yeah, the idea is just you need to just change this at layer control parameter. But yeah, okay, here we are, our snappyHexMesh, and we can actually run this snappyHexMesh. But first we must remember that our mesh is not in the poly mesh within the constant folder yet, so it is still inside this folder of 2 or whatever your like a control dictionary. So we must first copy this file and paste it here or replace it here by make sure it is deleted, the original one from the block mesh, and paste it here. And to avoid confusion, we just delete these 2 files. And here we go. We're ready to run our simulation. And this is basically just like the pitch daily, which we used previously in the like the tutorial of the internal flow, but I just make some change for the boundary. Let's say I delete the other empty boundaries and change the upper and lower wall to just the walls to to follow these boundaries: inlet, outlet, and walls. Make sure the name is correct, walls or wall, it depends on your preference. And here we go, just run our simulation. Okay, maybe we don't have to wait until it's finished. We just want to make sure that our mesh have no problem. Just like a touch again and reload. Wait a minute. Okay, reload the file, then here we go. Let's jump to the last time step and see the color of velocity, let's say. Here we go. Our simulation works well, or at least our mesh works well in this case.